everyone. My name is Voncarlos. It's a pleasure to be here to present. Thank you for the opportunity. I'm working the same project as the previous presentation in the Valley project, where we work with welfare and also artificial intelligence. And the title of my work today is Revolutionizing Livestock Monitoring, AI-powered crowd detection in farm environments, which is also is co-devised by Bilai and the others co-works. Uh, just just a brief summary about the work. I will talk about in our fair related works, challenges that we face, and the proposed approach, data set that we use, the results and the conclusion. Just a brief a summary about the animal welfare. Animal welfare is recognized as crucial for ethical, environments, and economic reasons. So here, for example, if you have like a helper and also uh, a good farm helper, and uh, we can use to a better improve the farms if you have like a healthier animal. Also, we can use these to produce gains. You up to 20% of increase of production due to healthier and less stress animals and farm. Also, we can predict some diseases. For example, some disease like we can predict in advance some disease. For example, lameness in the cows. We can predict, for example, the body of the cow, and to see if the cow has lambs or not in advance. And we can use uh, the machine learning artificial intelligence to make better predictions in the farm and to reduce the risk of disease and also to get like productive gains. Uh, but for this task, we have detection models that could be a base of to use in different tasks in the cow farms. For example, we can use artificial intelligence to make the cow count, cow behavior, tracking, and the geo positions in the farm, and also to make some predictions on the cow activity to see if the cow is, for example, eating or laying down or some of the different behaviors of the cow. Cow gait score, also the feed intake interval. You can see how many the cow is eating, and we can make some predictions. And also to make the identification and the recognition of the with each individual in the farm. So that's some of the tasks that we can do using artificial intelligence. And I will show here some work that used for the cow count. That's a work from Young 2023, where they produce a count system, more than 753 cattle, and that they use 14 video sequence where they divide in some frames, 30 K of frames, the top view of the cows. And they use as a model to detect yellow V8 that I will explain the next slides, where the detection rate was 87%. So in the image, you can see as input of the video, and the model output is the contability of how many cows is passing by from the video. And they have a where they put the camera. It's 3 meters and 7 meters from the farm. So here, so we have a type of the camera that they use, but our motivation for this work is if you have many different types of cameras, how we can work with a model detection. If you can make the detections different types of cameras or have some problems about light conditions, pose and orientation, background complexions, scale and size, camera angles and heights, and the occlusions. So if a model detection could be done a good work when you use those models when you have a different cameras. And here is the pipeline that we use. The first step is we use the cow data set as input, and we increase this data set doing the data augmentation, data expansion. After that, we use labeled data where you can take a bounding box in the cows just for the model, the object model, to identify instruct features from the cows and also to make the prediction and to detect. We split this data set in training and the test data set. And as a model building, we use the training data set as input for models, YOLO V5 and the mask RCNN. We train these models, and and then we test this model, and we compare and analyze the results in the final. Here's the data set collections. We have 3 different cameras in the interior, in the farm, and also outside of the farm. In total, we have 6 cameras that provide in the data set. That's the camera configuration that they split. We saw where's the cow, where's the camera is installed, and also the data set is divided in training set and test set. In the first data set, we have 244 images, but when we increase the data set, we go beyond and with 1,220. And we divide in interior cameras 610 and the exterior cameras 610. And in the test set, we not like augment, we just like keep in the same quantity. And that's how we separate the data set to validate your experiments. And here's the object detection model. The first one is called the mask RCNN. That work as input, we give the data set, and there is a backbone that's a convolutional neural network that's ResNet 101 that you use. And after that, these networks track the features from the image, and they propose a region proposal network where they select the best bounding box, the best detections, and after they use the whole Hoy analysis where they select the best bounding box with the best predictions. And the final have the softmax, and the class of this object is what kind of object is that, and also we predict the confidence of this detection, and we have the results in the final. And there is the hyperparameter that we use. The another one, it's called YOLO V5. That's another model detections that is the same like the same pipeline, but the difference here is they use another kind of backbone. It's called the darknet. That is more fast than the ResNet, is because they have fewer parameters, and also they have like the neck where they extract the features using a few bounding box, like small bounding box, medium, and large bounding box. And that's why sometimes this algorithm is better than another one because they focus in small objects to detect. And in the final, have the prediction bounding box, confidence score, and the prediction object class. And that's the hyperparameters that you use. And here is some results that we got for these models. We just compare the 2 methods, and we got, I will explain the first metric started by IP50 that we can, for example, measure with the area of intersection and the area of union. For example, if my ground true is the green, and also my prediction bounding box is the blue, we can define an area of a union. If this area is more than 50%, that will be a true positive in detection. So that's why we increment the precision of AP50, and to analyze the AP75 is the same way, but the area of intersections will be more than 75%, and the AP is the average between the AP50 and the AP95. This is the average. That's why we have like a few precision on that. And also ISML is meaning small detections, medium, and large. And we have the precision and the recall, and also the speed of the GPU when we reference the detection. And we see here the difference between the speed. Here it's because YOLO V5 is faster than Mascar CNN because we have here a small network that will be faster, and also YOLO V5 is working as just on stage detection, not like a two stage where they have a more step to analyze, extract the bounding box, and predict the detection. And here we have just the graphics to see if our model is not in overfitting, and we can see the loss and also the precision and the recall. As a as we validate also the data augmentation when we spend the data set, and we got the results for mask RCN and the YOLO V5, and we see that we increment a little bit the results when you use the data augmentation. Also, the precision and recall is up with the data augmentation for both methods, but YOLO V5 was better than mask RCN on this data set. And we can see here the APS for mask RCN is not so good, but when you use YOLO V5 because of the model, the architecture of the model, extract the few detections object, we can see that is possible to detect the counts far from the image. And here we just bring for some detections in the image, and we can see just the text for indoor environments, and you can see where I have background complexity. I have YOLO V5, that's better results. And also when I have the occlusion for YOLO V5, this is possible, is able to separate the both cows in the image. When I have the pose, the both algorithms was good. So if the cows is lie down or stand up, so we can see good results for both. And about the light, if we have like here the shadow, the both algorithms was good in this case. And here is the experiments that we did using outdoor environments. And in the yellow circle, you can see that mask RCN is not so good when you use objects far from and small object. That's why I have good results for small objects in YOLO V5. And also in the middle, we have like the false positive that is detected as a hood instead as a cow. And also have some problems with background and occlusions. And the last image, the detection is not like a total detection in the cow, and the YOLO V5 was better in this case. As a conclusion and the future steps, we can conclude that EI detection reduces animal discomfort, ensures stability over manual methods, and also the model generalize well across varied indoors and outdoors cameras, where I have a map of 91% with YOLO V5. Data augmentation improved 5.6% detection accuracy. YOLO is a little bit faster than mask RCN on this case. And our next step will be use this detection module to detect another parts of the cow, like body, head, and the snout for the cow behavior recognition. And also you can integrate this detection model to identify cow identification algorithms, and also in a last step we can enhance the detection model for tracking cows on the farm. So that was my work. So thanks so much for this.
Thank you very much, Voncarlos, for that very interesting presentation. Really cool how you showed the detection. And are there any questions here in the room for Voncarlos? I think we have 2 minutes. Yep, please go ahead.
Thank you for this nice presentation. My first question would be, Did you try other version of YOLO? Why stick to the version 5 now that we have version 8 and now
Mhm.
first version 9?
Yeah. We tried another kinds of YOLO versions like YOLO V8. Uh, yeah, so we just like did the first experiments using YOLO V5 and we got those results, but we are doing the another experiments using YOLO V8 under the mods that are update. But we need to measure if these models is better or not, because if you saw, for example, in the detections, YOLO V8 and YOLO V5 is depends of the tasks. They have almost like the same. YOLO V5 sometimes is better. YOLO V8 is better for some case, but you need to set how you can measure if YOLO V8 is better than YOLO V5.
Okay. And my second question concerning your result is, did you try it on some really unrelated cow video, Yomade? Because it seemed that you don't have so much image of cow,
Hmm.
and your dataset was kind of limited.
Hmm.
Does it apply once you train your model? Did you try applying it to other farm data that you
Hmm.
have or the
Yeah,
video?
yeah. That was my fault that I don't bring like the videos, but we have like many of videos where we use detection model, where you can see in different complexes environments, and we can see detection. Yeah, so but some cases where you have the occlusion is difficult to make the detection, and we try to improve the model for that. But yeah, so but we work with a lot of data set. We have a good data set, but that was the first experiments that we did. That's why I use a few data set, and we try to use the data augmentation to see if you can improve the detection model accuracy, and that's why we just bring those results as a preliminary. But right now we are working with more data set, and also you apply detections in real time for different environments.
Okay, thank you.
Mhm. Thanks so much. Welcome.
Thank you.